this is the last video from the chapter the P block elements. So today we are going to discuss group 18 elements. So first we'll start with the members. The members are helium, neon, argon, krypton, xenon, radon, oganesson. Occurrence among this elements. Okay, so all elements exist in atmosphere except radon and oganesson, as because these two are radioactive element. Okay, their abundance in dry air is about 1% by volume. Okay, so where your argon is the main constituent. Now helium and sometime your neon, okay, so they are found in minerals and radioactive origin like pitch blende, monazite, clevetite, etc. Then the main commercial source of helium is natural gas. Xenon and radon are the rarest. Xenon, radon, okay, are the rarest element of the group. Now this radon, okay, is obtained by decay product or obtained as decay product of radium. So radium, again, this is a radioactive element. So after disintegrating or after emitting radiation, okay, like helium or alpha particle, okay, this will disintegrate to give radon. So that means it is the radio active decay of your product or decay product of your radium. Now next is oganesson. Okay, so this is your synthetic radioactive element, and this is prepared by bombardment, okay, of californium and calcium. So californium ko massa 249, 98, calcium 48 and 20. So the two combine and give oganesson 294, 118 and your neutron. Now this oganesson, okay, so this is prepared in small amounts. So for that region the study of this element is limited. Next is atomic and physical properties. So we'll start with electronic configuration. So what are the members of group 18 element? Again, helium, neon, argon, krypton, xenon, radon, okay, and oganesson. So what is the electronic configuration? It is in period 1, right? So 1s2. In period 2, so 2s2, 2p6. Period 3, 3s2, 3p6. Fourth देखि d हुन्छ, right? So 3d10, then 4s2, 4p6. Xenon कति हो? 4d10, 5s2, 5p6. Radon, this is in 6th period, f start हुन्छ. So 4f, 14, 5d10, 6s2, 6p6. 7th मा छ. So 5f, 14, 6d10, okay, 7s2, then 7p6, and what would be its complete electronic configuration? Helium, okay. Then neon को, so अगाडि को छ helium छ, so 2 plus 2 हैन 10, then यता छ neon, then krypton को अगाडि हुन्छ argon, xenon को लागि हुन्छ तिम्रो krypton अगाडि, then for radon it is your xenon, right, and for oganesson अगाडि हुन्छ तिम्रो radon. So this is the complete electronic configuration for the member of group 18. And now what is general electronic configuration? So general electronic configuration हुन्छ तिम्रो 1s2, right, except helium, it is your ns2 np6. Next property is atomic size. Now we know that on moving down the group, what will happen to the atomic size? It increases, right? Increases. Why? Because of addition of your new shell, right? Now among, okay, this noble gas, noble elements, okay, have comparatively large atomic size. Why? So comparatively यिनीहरूको size के हुन्छ large हुन्छ. So whenever we talk about this group 18 element, so the interaction which exists between them is dispersion force, London force, van der Waals force weak हुन्छ. Okay, and whenever size को कुरा आउँछ या radius को कुरा आउँछ for this noble gas, so it is your van der Waals radius, van der Waals radius, and this van der Waals radius is greater than covalent radius. May and because of this the atomic size of group 18 element is comparatively large. Now ionization enthalpy, so again if we see the electronic configuration NP6, so it have completely filled orbitals, right? So for this region, so the ionization energy, okay, of group 18 is very high. So from it is very difficult to remove electron from such stable configuration. Then electron gain enthalpy, so again, okay, electron gain enthalpy. So for noble gas, okay, it is positive. Why? Again, the configuration. If you check the configuration, it have NS2 NP6 completely filled. So that means it will not have any tendency to accept electron. Electron accept गरेर कहाँ राख्नु, it's already filled, right? So for that reason, so to accommodate incoming electron in the valence shell, so we have to apply energy. So for that reason they have electron gain enthalpy with positive sign. Physical property, they are monoatomic, they are highly inert, right? So they have completely filled shell, so they exist as monoatomic element. Then their physical state, they are colorless, odorless and tasteless gas. And when we talk about its melting point, okay, and boiling point, so they have low melting point, boiling point. Why? So because yes, so they have completely filled shell, right? They have a comparatively large atomic size, right now, and the interaction which exists between them is van der Waals interaction or dispersion force, which is very weak. So for that reason it will have very low melting point and boiling point, and helium have the lowest melting point, so which is about 4.2 Kelvin. Okay, now when we talk about the chemical properties, okay, talk about chemical properties of this group noble group 18 elements. So they are inert, chemically they are inert. Why? The reason is very simple. What is the reason? Number one, so they have highest ionization enthalpy, right? Ionization enthalpy, and they have completely filled shells. Then they have positive electron gain enthalpy. So because of this three reasons, they are very so they are chemically inert, they do not form any chemical compound. But till the discovery of your noble gas compound, so that is compound of xenon. So the first xenon compound was XePt is PtF6, okay, and this was prepared by Neil Bartlett. Now what led to the discovery of this product? Okay, now he prepared compound with oxygen and platinum hexafluoride. Okay, what he got was this compound PtF6. Now red crystal. Now के भयो भन्दाखेरि, now since the ionization enthalpy, okay, ionization enthalpy and your first ionization enthalpy and atomic size, okay, so of oxygen were comparable with that of your ionization enthalpy, first ionization enthalpy and atomic size of xenon. भयो सो यिनीहरूको के थियो यो दुईटा प्रपर्टी अलमोस्ट सिमिलर थियो सो त्यसले गर्दा सिन्स अक्सिजन क्यान फर्म ओके दिस कम्पाउन्ड भनेपछि चाहिँ अब प्रपर्टी सिमिलर हुनुको कारणले गर्दा सो जेननले पनि कम्पाउन्ड फर्म गर्नुपर्ने हो भन्ने उसले प्रयासमा वाट ही डिड इज ही okay prepare the compound of xenon from your xenon and platinum hexafluoride. Okay, he prepared compound of xenon. So he got this compound. So this is the first noble gas compound, okay, compound of xenon. Now after the discovery okay of this compound so many compound of xenon were later synthesized using your fluorine and oxygen. So xenon form compound with only oxygen and fluorine. Now the question arises why. Okay, so as we have already discussed, this oxygen and fluorine are so highly electronegative, right? Electronegative, and they have small size, and also so this oxygen only can form multiple bond. Okay, so because of this reason, so this xenon can form compound with oxygen and fluorine only. Now there are compound of krypton also, which is very few, okay, and only your krypton fluoride is studied in detail. Now compound of radon has not been isolated so far, but okay, it is identified by radio tracer technique. Compound is here radon difluoride, and there is no such compound of argon, neon, helium. Why? Because their ionization enthalpy is quite large compared to their krypton, xenon and radon, which lie below in the periodic table. So now let us discuss the compound of xenon and fluorine. So there are number of compound having formula XeF2, XeF4, XeF6. So they can be prepared by direct combination of xenon and fluorine. Okay, both are gas. They give xenon fluoride. When the two are reacted in 1:1 ratio, 1:1 ratio. Okay, when xenon and fluorine, little excess, if it is reacted in 1:5 ratio, okay, we'll get is xenon tetrafluoride. And when the same, when fluorine is taken in excess amount, okay, then that is 1:20 ratio, then we'll get is xenon hexafluoride. And all these are solid. And this xenon hexafluoride can also be prepared, okay, by reacting xenon tetrafluoride and O2F2 fluoride or oxyfluoride. It will give fluorine eta jन्छ, so you will get XeF6 plus O2. So all these are solid. Now the properties. So all your xenon compound are colorless, crystalline, solid and sublime readily at 298 Kelvin. Okay, they are strong fluorinating agent. They readily they are strong fluorinating agent, and they readily hydrolyze even by trace amount of water. Even if trace amount of water is present, okay, they will get hydrolyzed like XeF2. भयो त्यहाँ सपोज वाटर छ, यो के हुन्छ हाइड्रोलाइज हुन्छ, डिकम्पोज हुन्छ टु xenon, and H र F ले HF दिन्छ and oxygen. Okay, 4 2. And I've already told you that this xenon, right, these are strong fluorinating agent. Okay, they either act as fluorine donor or fluorine acceptor. Like for example, okay, so here your xenon fluoride will act as fluorine donor. Okay, PF5. Now what it will donate fluorine to your phosphorus pentafluoride. जस्तै it will give Xe भयो, यसले के गर्यो एउटा फ्लोरिन लाई दियो, राइट, एउटा फ्लोरिन दियो यसलाई. सो इट लस 1 फ्लोरिन, सो क्याटायन मा कन्भर्ट हुन्छ. Okay, and this gain 1 fluorine. So पहिला 5 वटा, then now it have 6, right, anion ma. And sometimes it act as fluorine acceptor. जस्तै xenon hexafluoride एक्सेप्ट गर्छ फ्लोरिन विथ मेटल हेलाइड ओके सो यता के गर्छ यसले दिन्छ यसलाई सो इट विल नाउ मेटलले के गर्यो लुज गर्यो इलेक्ट्रोन फ्लोरिन राइट सो इट विल नाउ अक्वायर पोजिटिभ चार्ज देन xenon पहिला 6 वटा थियो अगेन अझै एउटा गेन गर्यो सो 7 after gaining it will convert to anion fluorine anion fluoro anion then this metal so it can be your sodium potassium rubidium or cesium that means alkali group is a compound of xenon and oxygen okay so it can form number of compound with oxygen too okay so like XeO3 okay XeOF4 XeO2F2 now so hydrolysis of XeF4 okay will form your XeO3 र अर्को byproduct हुन्छ xenon and HF okay and oxygen so oxygen xenon प्राय निस्किन्छ याद गर्नु त्यहाँदेखि xenon hexafluoride okay on hydrolysis it form xenon trioxide and 6 mole of your hydrogen fluoride. Now next a partial hydrolysis of Xe okay F6 gives only oxyfluoride like XeOF4 or XeO2F2 just the xenon this is complete hydrolysis. Now second is your partial hydrolysis के दिन्छ यता XeOF4 okay and XeF6 H2O XeO2F2 र byproduct मा हुँदछ HF so partial ma you will get either XeOF4 XeO2F2 but in complete hydrolysis you will get XeO3 next properties okay now this XeO3 is again colorless explosive solid and have pyramidal structure we'll study the structure later then XeOF4 colorless volatile liquid or a square pyramidal molecular structure now next last is your uses of noble gaseous so helium is used in filling balloons for meteorological observation you're highly non-inflammable and light gas so it is used in gas cooled nuclear reactor dilutant oxygen in modern diving apparatus यो हामीले this यो second chapter that is solution मा पढेको छ instead of using nitrogen we usually dilute oxygen with dilute oxygen भनेर why because the solubility of helium in blood is very very low the next is helium okay is used as a cryogenic agent helium is used to produce and sustain powerful conducting magnets which is essential part of modern NMR spectroscopy MRI system ma चाहिन्छ the neon discharge tube fluorescent tube bulb ma for signaling or display of the advertisement and neon bulb are used in botanical garden greenhouses ma neon is used in regulation and indicators okay voltage regulation and as indicators so argon is used to provide inert atmosphere in high temperature metallurgical process or lab ma pani if you need the inert atmosphere then argon gas is used so argon gas is used as rectifier then krypton okay is used in high efficiency miners helmet lamp etc now let us discuss some compound structure of xenon compound so first we'll start with FeCl2 now first we have to know the hybridization state right hybridization state kati huncha so xenon it belong to group 18 so valence electron is 8 plus there are two monovalent elements so 2 divided by 2 gardakeri 5 so that means it will have sp3 4 by with d5 and structure huncha timro Xe okay F so never place lone pair at the axial position so place it in equatorial position where it will experience minimum repulsion so this shape is what called linear हैन एकदम सीधा straight line जस्तो देख्दैछ त्यसरी नै XeOF2 so again if you find out the hybridization state it will have the same like sp3d Okay, so त्यतिबेला Xe, what would be the structure? So oxygen, दुईटा प्लेसमा your lone pair, and axial position where there will be a fluorine. So this is what called T-shape structure. Okay, now your XeO3, if you check the hybridization state, so 8 divided by 2, 4 hunja, so it will have hybridization sp3. So xenon, okay, oxygen, so every time oxygen is divalent element, it will form double bond. Okay, and xenon, there will be a lone pair, so this will have pyramidal structure. So this is how we do the structure, or we draw the structure for different compound. Thank you all.